Hi guys, in this video we are going to talk about how we can create a YouTube RAG application. So the concept is that let's say you are following multiple YouTube channels and you want to basically create a knowledge base out of those channels, right? So that you can later on ask questions and get the relevant answers from that particular channel, from that YouTube channel. So what you'll do is basically you will ask question and then you get the answer from that particular channel, and then you also get the YouTube video, that particular video which will be relevant to that question which you have asked. So for example, I'll take my channel's URL and I'll go to the YouTube RAG application and provide the channel URL here and click extract and create knowledge base. So as you can see, it has started fetching all the information from that particular channel, and there are 9 videos. So what it has done is it has fetched the metadata of those 9 videos, and now what is happening is it is extracting all the transcript of all those 9 videos which I have in my channel. So now we can see we have the knowledge base created successfully. What we'll do is we'll go to the YouTube RAG, and in the YouTube RAG I'll select Ayanch Roy. So what we will do is that now you can ask any question from that particular channel. So as you can see, I have created few of the videos, and one of the video is about function calling. So what we'll quickly do is I'll ask what is function calling, and the moment I'll click enter, so now you can see the answer to my question is here. And the good part is basically we have the source chunks and the videos. So this is the first chunk, second chunk, and you can see that all these chunks are related to function calling, which is correct. My expectation was also that it should only pick the information from the vector DB about only function calling, because my question is regarding function calling. So yeah, so that's it guys. We are going to learn like how we can create this YouTube RAG application where we can clone any YouTuber so that we can have that information, whatever videos he has created, he or she has created, we can interact with that particular knowledge, right? So let's quickly go and check the other aspects of this video. So before jumping into the code part, let's understand the architecture of it. So provided the URL of the channel, you basically provide the name of the channel, and then what happens is this Scrapetube is basically a package which takes this URL and gives all the videos of that particular channel. Then what happens is I have kept a loop which will every video IDs and then do a HTTP GET request to the YouTube, and it'll fetch the metadata of it. So basically like the title of the video, the description of the video, the external URLs which have been mentioned. So all these information will get fetched, okay? Not the transcript. So transcript will get fetched using one another package called YouTube Transcript API, okay? So once this transcripts will get fetched for each and every video of that particular channel, we are creating a text file, okay? And then as you have the text here, so this is a very generic RAG pipeline which you can see in your screen. So think of it in this particular use case, we have all the text of transcript and all the metadata of those videos, okay? And then as usual, what happens is it gets extracted from these text files, converted into chunks and then embeddings, and eventually it gets saved into the Qdrant Vector DB, okay? And from the user perspective, you will have this pipeline where the user is using STREAMLIT app and it is asking question, and as you have already seen in the demo, right? So you are going to ask any question, and then that question will also get converted into chunks and then embedding, and then basically the retrieval part will come into picture where we will be having a similarity search and then top K
similarity will get fetched and it will go to the LLM. And in this case, we have Gemma, 2 billion LLM, and that LLM will take care of the synthesis of all the retrieved chunks, and basically we'll get the answer of it. Okay, so this is how the whole pipeline is working in this use case. In the code part, we have mainly 3 files: app.py, LLM service, and YouTube service. So we'll start with app.py. In the app.py, we have around 4 functions. We have scrape YouTube, then create trans text file, create channeling, and fetch transcript. So I'll quickly go through each and every functionality of it. So you can see in the first page, what we are doing is we have YouTube channel link, which is the text.input, and then we have button. So the moment we click this extract and create knowledge base by giving the channel link, what it is doing is basically it is giving us all the video ID list, and this video ID list, we are passing it into the scrape YouTube. So once we go to scrape YouTube, we can see we have a loop with the progress bar in the UI part, and we are having a request.get by passing the URL of it, and then we are fetching these information from this soup object. Okay, and then eventually we are creating the data frame out of it. Okay, and then we are saving this data frame. Where we are saving, we have the data folder, and in that folder we have the name of the channel. So we have Ayanch Roy, which is my channel, and then Midnerd. And in these, we have the CSV file also. Okay, so this CSV file has nothing but the title, channel, description, video ID, external links, is trans, fetched, and transcript. Okay. And then basically what is happening is, let me quickly go back. So once we have the DF of it, data frame of it, we are fetching the transcript. So one thing which we can basically tweak in this example is that what I'm doing is I have 2 for loops. One is for fetching the metadata using the request.get, where I'm fetching the title, external URLs, the description of the video, and the other one is only for fetching the transcript. We can merge this, and it could be a tweak for this application. But yeah, so that was how I have coded. So in the fetch transcript, again, you can see I have taken the data frame and fetching the list, description, channel, video ID, and is fetched or not. And then basically I'm adding one more column to it called transcript, and basically I'm having a loop here and fetching the transcript and creating the file, the text file of the transcript. So each and every channel, we have the number of text files. So these text files are nothing but the particular video information. So if we click one of them, go up, you can see this is the video title. This is the channel name. This will be the description of it. And then the actual transcript is starting from here. Hi guys, in this video I'm going to show. So same goes with each and every text file. So all the text file will have these information. We are creating this text file for each and every videos. Okay, and then you can see for each and every video, we are also creating the knowledge base. So knowledge base will be always 1, but it will hold all the videos of a particular channel. Okay, and then how we are creating knowledge base. If you go inside the create knowledge base, we can see we have the text loader, and in the text loader, we are providing the video text file. With the loader.load function, we are getting the documents, and we are using the recursive character text splitter, giving chunk size as 1000 and chunk overlap as 100. Then we are getting the chunks, and basically we are uploading it into the Qdrant Vector DB. So if I go to Qdrant Vector DB, you'll have a better understanding. As I said, each and every channel will have its own collection. So Ayanch Roy has its own collection. If we click on the info part, we can see that vector counts are 390. And then if we go to the other channel, which is comparatively having a huge number of videos, we can see the vector count are 2811, right? So these are the two channels which we have created, and we can see it has created the collections here. We are making the transcript, we are saving the transcript in the transcript column, and then we are saying is transcript fetch is true because we have already fetched the transcript for this particular video. And then we are again saving this data frame back to the folder. So you can see this is the .csv data frame which we are saving as a .csv in the folder. And then we are saying knowledge created successfully. So this is basically the logic which is present in the first page. This is what we have discussed. And if you go to page 2, now in page 2, what happens is the moment the knowledge base has been created, right, it'll show up in the select channel. So in the select channel, we can see there are 2 channels. The moment I click on any of this channel, what will happen behind the scene is it will plug in that particular channel vector DB to the RAG, okay, to the RAG pipeline. So now if I ask any questions, it will be answered from the Qdrant Vector DB Ayanch Roy, right? And if I click on the mednerd, the vector DB which will be responsible is mednerd. So let's do one thing. I'll delete my channels dataset, and then we will re-extract all these information again. And then once we'll do that, we will basically come to YouTube RAG, and I'm going to select my channel's name here, and then we will ask questions from it. So I'm going to copy my channel's URL and go to the application. In the application, I'll select the YouTube data extractor, and then I'll paste the link of it. Then I'll click on the extract and create knowledge base. So first time, the progress bar is showing the extraction of metadata. The second progress bar is showing the extraction of the transcripts. As you can see, we have no connection could be made because the target machine actively refused it. And if we come back here, we can see that we have, where is it? We have exception in create KB. I know where it got failed. So I have run the container of this Qdrant DB so that we don't get this exception again. I'll click on extract and create knowledge base again, and we'll see what happens. So the knowledge base created successfully. We'll go back to the VS Code and check if we have the data again. Yeah, we can see that Ayanch Roy channel folder has been created, and we have the CSV created, and we have all the text files of each and every video, right? So we'll go back to UI and check if we have it here. So select channel, and we can see Ayanch Roy is here. So the moment I'll click Ayanch Roy, I can see the CSV file which we have saved, and it has title, it has the description of the video, and it also has the external links and the transcript, right? So we have till now 8 videos, so there are 8 rows, right? Okay, so what we'll do is we'll quickly ask one question. So you can see there are questions which I have already asked from this application. So what I'll do is, because I had created a function calling video, what we will do is we'll ask what is function calling. And here we have the answer. Sure, here's the answer to the question. Function calling is a technique used to extract structured output from large language model like GPT model and blah, blah, blah. So you can see like it has given us the proper answer. from the from the saved function calling, from the saved transcript. So this is the whole transcript of that particular video, and we got the answer. The good part is here we can also see the source chunks and the videos. So as you can see, this is the chunk one function calling, which maintains the format each and every time you call this function. And then you have the video also. So in the chunk 2 also, we can see the correct video has been fetched. In the chunk 3, you can see this is the wrong chunk which has been picked up, and you can see the wrong video is also being picked up. And then the fourth one is correct because it talks about function calling. Fifth one is also correct where it talks about the function calling, right? Out of 5, I would say 4. There's only one chunk which has been picked wrongly, but overall, we see that the large language model has done a good job and has given us a very good answer, right? And in this case, we are using Gemma large language model. If I go back, you can see. So this is what happened. So I basically asked a question, and then it goes chunk, and then embedding, and then basically the retrieval part has fetched the k equals to 5 chunks in our case, and the LLM which we are using is Gemma. Okay, so we have already seen the code part for the first page, which is YouTube data extractor, but let's quickly go through the YouTube RAG. What is there in the code? So we can see this is the page. This is the second page, YouTube RAG page, where we are listing the channels. So how we are listing it? We are basically, if we come here, we can basically listing the directories. And we go to UI, we have these 2 folders, right? That's why you can see these 2 folders, Mistral and Midnight. And that's how we are basically passing it to the select box of the Streamlit in the sidebar, right? And then we have a text input where we are getting the user query, and once we have the user query, we are calling the LLM service.getResponse with the channels selected and the user query. So once we go here, we can see query, and we can see we are creating the DB object from the Qdrant, and we have written the retriever part where we are passing k equals to m and search type equals to mmr, and then basically we are initiating the chain, the question answering chain, by providing the prompt. So what is the prompt? Prompt is again the prompt template object, and in the prompt template object we are passing the prompt template. So this is the prompt template text. We have given the context provided. I will consider the relevant information to formulate a detailed and well explained answer to the user's question. If the answer is not within my knowledge base, I will clearly state that I don't know, right? So this is basically to avoid the hallucination, right? And then we are passing the context and the question, and I'm again saying like, okay, I will not process the information and provide a helpful and comprehensive answer. In the get response, we have the question answer retrieval QA object, and we are passing the query, the user query, to this QA object, right? And then we get the response, and basically we are extracting the result, which is the answer of it. Now, in the response, we also have few metadata information. One is the source document, where basically we get the chunks from. So if I go back again to this particular visualization, we can see that these are the retrieved chunks. So for our case, k equals to 5, and we have used the MMR type of search, and we have the Gemma LLM. We can see we have source docs and all the chunks, which we are basically showing in the UI. So you can see these are the chunks which has been fetched from the retrieval, and we are also showing the respective videos. We have used the OLLAMA. You can see this is the OLLAMA, and we are creating this OLLAMA object, calling it LLM, and we are passing the particular model. So right now in this use case, I have used Gemma, that too of 2B. I have not used 7B. 2B is giving me sufficient, I mean, it's giving me very good result. That's why I did not switch back to 7B. So it's up to you guys. If you guys want to, experiment with another LLM, be it like Phi, be it like Tiny Llama, or whatever you want, or maybe if you have the OpenAI, key, then you can definitely use the OpenAI. So that was it. I mean, I think you have understood the second page functionality also. So the moment we are asking the question, it is basically giving us all this information, the answer, and then basically the source chunks with the video, right?